Good evening, madam. We all are at one location, madam.
Okay, thanks. That will be a good arrangement. Thank you very much.
Yes.
I will start now. Back.
Another.
Yeah,
That's it.
yeah, we have got sufficient audience here. So, am I audible to you? Can you hear me?
For us, okay, madam. Well.
Okay.
Bright face.
Okay. Thank you very much. Then, good evening to all of you who joined us today to listen to the eminent panel who will present their first-hand experience on the application of soil cement bentonite barrier wall in augmentation of Kalmadu Reservoir in Northern Province. I am Mrs. Kamaladasa, Chairperson of the Water Forum. I would like to welcome you all to this event, even though we all meet remotely due to many practical limitations, but hope we can discuss without considering that limitations. Anyway, if I briefly introduce the subject we are going to discuss today, it is based on the observations made and experience gained during the implementation of Kalmadu Reservoir Augmentation Project in Kilnochchi district, managed by the Irrigation Department in Northern Provincial Council. And this project is executed through a project funded by the World Bank. This work includes an unconventional method of dam rehabilitation. That is why Engineer Sudhakaran and the team selected it to share their experience, their valuable experience with the other members of IESL. Thank you very much for the whole team, and especially Mr. Sudhakaran, who spearheaded in selection the topic and then organizing the panel. So it is the use of the soil cement bentonite wall, the alternative type to the conventional clay core on the embankment, that gives more benefit than the usual clay core. So that is what we are going to listen to them and grasp what is the difference between these two. So on our invitation, Irrigation Department, Northern Provincial Council agreed to share its first-hand experience through this IESL monthly water forum event for those interested technical personnel to explore this modern day implementation technique. There will be 4 panel members who will share their experience today. Once their presentation done, we will allow the discussion, and I earnestly request the audience to post your questions to the chat box during the proceeding itself before you forget the questions. So we will collect all these questions and direct to the panel once the whole panel members' presentations are over. So I will introduce the panelists one by one without taking much of time, because we have to allow the panelists to discuss, present their findings. The first panel member is Engineer Sudhakaran, who needs actually no introduction to most of the audience here. Anyway, as a tradition, I will make a small note. Engineer Sudhakaran is he graduated in 1997 with BSc second class honors degree in civil engineering from the University of Peradeniya. He commenced his career in 1998 as an irrigation engineer at the Department of Irrigation in Northeast Provincial Council. He is presently the Provincial Director of Irrigation in the Northern Province. So he has more than 23 experience out of his whole engagement in the Irrigation Department in Northern Province. Out of that, 23 years of foreign funded project in different capacities, especially including the project director post in the Kalmadu Irrigation Development Project. He has published 6 publications in international forums, 6 publications on national forums, and 2 public awareness articles too. He is a fellow member of IESL and a very active member of the Executive Committee of Water Forum. He received commendations for outstanding contributions to ISL for the activities in the capacity of chairman of ISL Wadakin chapter. Further, Engineer Sudhakaran actively involves in the corporate social responsibility activities in different capacities, especially in Rotary Club in Kilnochi, including the president. He held the presidency in one term, and he's an all-island justice of peace. Also, that according to the biodata I received. Engineer Sudhakaran, it is your floor now. Thank you so much for your involvement in this panel, in organizing this panel discussion. Over to you.
Thank you, Madam, for the long introduction about myself, and thank you for giving this such a wonderful. Can you hear me, Madam?
Yeah.
Yeah.
Can hear. Yes.
Yeah. The wonderful opportunity given to Northern Provincial Irrigation to share our hands-on experience on the application of soil cement bentonite barrier wall to be being constructed under the Kalmadu irrigation scheme. So once again, I thank you to good evening, all of you, my dear colleagues. So I try to give the experience to all of you. So as explained by the madam, so this is the presentation, my synopsis. So the rehabilitation of Kalmadu schemes, basically the ongoing upgrading project by the Irrigation Department Northern Province under the IWRMP, the World Bank funded project. So we have made augmentation or upgrading to many irrigation schemes. That is the latest, the Kalmadu during the post-war era. Before that, we didn't get such a chance. Now we have got a number of chances to meet the current increasing sectoral demand. We are now not limited to the irrigation schemes, so we are giving to the other sectoral demands. So this work includes, as explained, the unconventional method of soil cement bentonite barrier wall. So as you know, SCB wall gives more benefit than typical clay core, and now it's not uncommon for the irrigation department, as you might know that. So we already involved in the Pera Reservoir in Baunia during 2015, where SB wall only constructed. After that, in 2016 and 17, so under Irrigation Reservoir, we introduced SCB construction. So similarly, it's the same way with this time, Kalmadu Reservoir, the augmentation project have been undertaken through the SCB wall construction. So this is the idea. So we get some exposure on that. So this has to be disseminated to the all of our colleagues, especially engineers, to aware of this, the modern day implementation technique. Everyone should know that. So whatever we learn, we can share it. So accordingly, so this is the presentation topics. So we divided into five areas. Mainly, I will cover up augmentation, upgrading, or modernization of irrigation reservoir headworks in Northern Province, not limited to the Kalmadu. I will talk about all. So similarly, my other colleague, Engineer Karnanidhi will talk about particularly on the augmentation of Kalmadu irrigation reservoir. He will take 20 minutes. The followed by him, Engineer Vaigaran, he will talk about the fundamentals of SCB barrier wall. He will basics of SCB wall. He will talk about within 15 minutes. Thereafter, construction and quality assurance in SCB wall barrier in Kalmadu. So Engineer Sunoj will continue. So end of the process. So after that, so we try to cover up particularly this SCB wall construction, starting from excavation to preparation and application. That way, we have prepared the nice video clip, also 5 minutes. So altogether, we try to complete our presentation within 150 minutes time. Please, everyone, cooperate with us. Definitely, it will help. It will acquire some knowledge from us. So please cooperate with us without leaving from this Zoom. So with that, this is my topic. I will cover up within 15 minutes time. So that is, I am going to talk about augmentation or upgrading and modernization of irrigation reservoir headworks in northern province, because as you know, so we do. So we have by doing augmentation or upgrading, mainly for increase the capacity to for the additional command area or irrigable area. So beyond that, now we do some modernization also. So particularly this is increase the operability. So we need to increase the operability. We do some modernization also for the Irrigation we did. So I will talk about that also. So basically, so after post-war era, so we do number of augmentation, upgrading, and modernization. I will talk about that within my presentation. So I see before going to the modernization, so I should aware of how the irrigation system in northern province particularly. This is the overview of river basin in northern province. As you know, we always talk about, so we are fortunate in God gifted water resources in northern province. As you know, out of 103, so 24 river basins are running through the province. So we are rich in water, very proud to say that. So of which, as per the 13th amendment to the constitution, you might be aware of that. So we have the provincial river basin. So the out of 24, 18 are provincial river basin. So that handled by our irrigation department. Basically, if you take Kanagarayanar river basin within the provincial river basin, so we do handle this schemes like that. So there are some interprovincial river basin as well that handled by the central irrigation department. So that way it is handling. Through this system, the river basins, out of 18 river basins, we are handling around 54 major medium tank under our purview. So that every district I am showing here. So this is the major team. Out of 54, we maintain 9 major schemes, including Irrigation, Muttiyankattu, Vaunikulam, like that. There are 9 major schemes also we are maintaining. So if we come to the point, augmentation, upgradation, modernization. Yes, that's what I'm trying to. So we do. So because as you know, so we are in the tail end of the river basin. So there's an opportunity or there's a potential for harvest the water through the augmentation. So we do. So under the rehabilitation, we do improvement as well. But we are very much concerned about the augmentation, upgrading, and modernization. So augmentation, upgrading same. So we do upgradation and modernization as much as possible for the irrigation schemes. So if we come to the first scheme, we augmented or upgrading and modernization. Irrigation scheme, you can see this is the largest major tank in northern province. Originally constructed in 1902 by the irrigation department. This was the before the augmentation of stage you are looking. So, but if you see the history of upgrading of augmentation of the Irrigation, as I told, this was originally constructed in 1902 started. First augmentation to the full capacity of 40,000 acre feet. The FSL only 24 feet at that time at the 1920. We are proud to say the irrigation department itself, the first tank built by the irrigation department is the Irrigation, we learned. So accordingly, we constructed that time. So then if we come the second of the augmentation during 1948 to 51, where we could able to increase 24 feet to 30 feet. The capacity also increased to 40,000 to 82,400. The third augmentation, so that 1954, 56, where we could able to bring up to 32 feet. So every augmentation we do because this is a settlement scheme, remember. So people are from mostly Jaffna, from other part of places. The people are settling based on this augmentation. So accordingly, the land holding patterns are lands are given to those settlers. Accordingly, this augmentation happening. So thereafter, there are fourth augmentation that was the last before this recent augmentation in 1775, where the last capacity, that is a 34 feet of. I think last 25 years we maintained 34 feet of the 106,500 acre feet. It's equivalent to 131 MCM of water we stored after this fourth augmentation. But as I know, there's a potential. So this is a tail end of the what he calls the lower reaches of the Kanagarayanar. So there's a possible of augmentation still. So accordingly, we recently, after we couldn't do anything during the war period, so we could be able to augment. It's a fifth augmentation during after the post-war era. So there are a number of agencies willing to assist us. Accordingly, ADB assisted in 2013 to 2018 around 2,000 million spent for this augmentation. So we increased the capacity by 17 MCM. So by increasing 2 feet of height. So this is design and supervision consultants by private consultant firm honestly. So because we don't have such exposure during that time in 2009-10 period, we don't know such exposure. We compelled to hire one consultant firm Infotech. So we are some international consultant. So who came and did design and all. So that's the case. So this is the typical cross section of the dam embankment. So normally we do 3D anime things. So according to this is the increased capacity of 17 MCM as I explained. So this is the new thing I want to emphasize here. We introduce SCB wall construction here also in order to increase the what you call clay core height. So prevent the seawater intrusion, because this is number of time augmented, but we couldn't extend the clay core because. So now we compelled to do the core extended core extension cannot by clay core. It cannot be done. We have to cut the bund and all. So that's what this technique has been implemented. So like that, there are 3D views of the Irrigation. So now you can see similar phases in Irrigation. So recently completed. So this is the way we have completed. And before the design, during the design, we developed this 3D models. This is some of the construction phase of a dam embankment. So I don't want to explain. So number of photos. Basically, I trying to show is this SCB wall has been introduced here in order to extend the clay core wall. So that little offside upstream side. So we are the 2 feet of cut and wrench slurry wall, slurry is port. So that way is constructed. I don't need to explain. You will see in Kalmadu as well. Similarly, other construction we introduce what he calls drains, sand all, everything, sand, simini, every as per the design given by the international consultants, engineer Barrat, we did with everything. So this is some of the photo. This is some of the photos. So similarly, this is the completed view of Kalmadu Dam. You can see that this is the Kalmadu Dam nicely appeared now. Yes, everyone knows. So this is a Vaunikulam irrigation reservoir. This is the before second tank reservoir. That is a Vaunikulam that is in Mullaitivu district, where we through the ADBI system we could able to increase the capacity, for which also design and supervision consultant by the CECB consultant, not by directly by irrigation department. Still we have some lack of exposure during that time. So this is the some of the photos. This is a completed view of the Vaunikulam tank. You can see the Vaunikulam, how we augmented. So now people are realizing the impact out of this augmented. So even in Irrigation also we could able to increase the cropping intensity. I am proud to say the earlier it was only 1.4. Now it's more than 1.85, or sometime last year we could able to reach 2 also. So that is the case. So this is the Muthiangada other major tanks, the second major tank in under our purview. So where we do the updation and the modernization. Even Irrigation also I didn't mention that where we did the modernization as well. So all the gears, what you call this manual operation brought by what you call electrification and doors. Now its operability has been increased. So that means the modernized scheme. Like that, Muthiangada also modernized. Capacity increase, this design. So when we are started slowly, we are moving towards that design and supervision consultants by the irrigation department, Northern Province. So we did all design and all after experience from the Irrigation and all. That way it's happening. So this is some construction photo from Muthiangada. So that is so this is the fourth tank, is a Kalmadu tank. So we are now augmenting now, but unfortunately, so during high intensive war, this tank was breached or intentionally breached. So that need to be restored. So in 2019, so we could able to immediately after the resettlement, we need to restore. So fortunately, we could able to within a short spell of time, we could able to complete. That also really at the time, very limited engineers and all. We did some design and supervision accordingly. This bridge has been completed. The bridge is around 100 meter width and depth also around 30 meters. So we could be able to fill it by our conventional methods. No any SCB wall and yes. This is some typical section of the what you call Kalmadu. This is a 3D model. So as I told, as much as possible, we do what you call 3D. Some of the photos of that time. I'm talking 2010, 11. That time we did similar work on that. So this is a restored view of Kalmadu tank. So now in tech, because immediately within 2 years time, we could be able to give the water to the farmers, the resettling farmers. So very happy about that. So very grand way this opening held in 2012. So then, so overall, I can say, like I have shown only four schemes. Like out of 54, 19 scheme has been augmented or upgrading and modernization. So accordingly, I can proud to say the earlier before 2009, there's a post era, only 316 MCM of water we had. So now I can say another 62 MCM of water. So I can say half of Irrigation. So we stored like Irrigation with 17 MCM. Muthengata 6 MCM like that. So 62 MCM of water has been augmented through our schemes. So recent it's a big thing for us because we are dealing with a comparatively small scheme, but still we are augmenting as much as possible. So the augmented storage 62. So, but if you see the water balance of Northern Province, so as present, we have existing storage of 680 MCM to be stored for the, as I told, for the sectoral demand of water supply and tourism, everything. We need another 359 months. But we have plenty of water. As I told, in the 18 river basin, we can harvest 3,460. But we don't want such huge quantity. Only we need the 359 MCM. So accordingly, still further, so I can try to say still further upgradation or new construction are required. So for which Madam knows that we are doing, we have the river basin wise proposal. For India 18 river basin, we have the river basin proposal. Recently, according to the Madam leadership of guidance, we are going to do the Paliyar Reservoir. So under the Lower Paliyar Reservoir, under the Paliyar Reservoir, so where that water is dedicated mainly for the water supply to Jaffna and all. So what I'm trying to say, still possible, augment or new construction possible. So we have the proposal. Accordingly, we are working and not limited to earlier one. So this is the prioritization and the selection. So why this Kalmadu has been selected for this immediately? So we have list of proposal, more than 50 proposal we have with a very detailed, but basically, so what you call Kalmadu is a bad status out of other schemes, mainly Headworks. So only during the war times we only restored only the bridging section. Others are get bad section. So beyond that, the last tank in the Netaliara catchment. So as I told, this is last. So every water goes to the sea. So definitely we can possible of augmentation. Beyond that, so economically it's a viable project because there are land, plenty of land. And not only that, we can give the water to the other sectoral demands. So the climate resilience also we have to address. So as I told, or this upgrading or any augmentation not limited to the additional capacity. That address for the climate changes. So the recent climate change also we have to address. Accordingly, this has been prioritized, selected. Accordingly, this project proposed to the World Bank in 2018. After this restoration, they agreed. Augmentation, they agreed. So accordingly, World Bank assisted us to around 700 million under the IWRMB project. Accordingly, this has been going. This SCB wall and everything is coming. This is how, again, I am proud to say, the design and supervision consultants by the irrigation department. As you know, Irrigation started with the private consultant, then CECB. Now we can able to do the design and supervision of the any of the dam. I don't say we can do that. So accordingly, this is our overall my picture. So my engineer, that's all about my presentation. So from that point, so Kalmadu, he will take over from this point to explain about the augmentation of the Kalmadu. That is the second presentation. Thank you everyone for listening. During the discussion, as mentioned by our madam, we will definitely go for a any question, or you can SMS message it. We will respond as much as possible. Otherwise, later on also we can do the best best. Thank you everyone for listening.
Yeah.
Good evening.
Thank you very much. Thank you very much, Mrs. Dakaran. I think it is a very concise overview that paved way for the other panelists to explain their part of the presentation. Actually, now it is not extending the core wall. It's a very common mistake done by the by most of the engineers when heightening the dam. So your team has nicely picked up this technology from your first experience in Kalmadu. Congratulations for that. So with this small comment, I will introduce the second speaker of the panel today. He is Engineer A. Vaiharan. He is graduated.
Madam Karnal, Engineer Karnal.
I'm sorry, the order given to me was that. Sorry about that. Okay, Mr. Karunanidhi will be the second presenter. He graduated in 2001 with BSc Honours degree in Civil Engineering from University of Peradeniya, and he commenced his career in 2008 as an irrigation engineer at the Department of Irrigation, North East Provincial Council. He is presently the Deputy Director of Irrigation in Kilnoch Range in the Northern Province. So he has more than 15 years of exposures of foreign funded projects with the different capacities, and he is a member of the ISL. Over to you, Mr. Karunanidhi.
Good evening to all. My name is Karunanidhi. I am the Deputy Director of Irrigation, Kilnoch Range. Before discussing the Kalmadu rehabilitation matters, we will see the exact location of the Kalmadu tank, because this is the tank is situated in Northern Province. I think you can see the location of the Kalmadu tank. Yeah, then we will think about the history of the tank, because it was restored in 1951 to 53 to irrigate 450 acres of paddy land. Then the second documentation was done in 2003 to irrigate 3,450 acres. In 2009, the man-made disaster was occurred in 2009. Thereafter, no cultivation 2 years. Then urgent restoration was done in 2011 to 2012 under the leadership of President Director under the funding of World Bank. The third documentation is in progress at now. This is the hydrology. The main feeder stream of the Kalmadu tank is Nethaliyaru. In the Nethaliyaru river basin, only one Kalmadu tank is available. Then we are receiving frequent water flow towards the Kalmadu tank. Every year we are sending more water to the sea without any usage. At the same time, the farmers of the Kalmadu also, they are requesting more water to do the cultivation. I think augmentation of the tank is possible. In the meantime, some other data are given. Catchment area and capacity and water spread area and other details are given here. This is the present hydro data of the Kalmadu tank. The present capacity of the Kalmadu tank is around 12,280 acre feet, and other data also given here. Before going to the Kalmadu tank rehabilitation matter, first we will think about the common issues in the tank. Normally, in every tank, the seepage and piping is the common issues. Normally, due to the seepage and piping issues, the internal, that is normally called as internal erosions. The embankments, inside the embankment, the particles are removed by the seepage water. Sometimes it may create very huge disaster in one day. In the meantime, there are some upstream and downstream erosion also happening. That is normally we are calling as external erosions. These are happening due to the unprotected cover to the embankment. This is also one of the major issue in our tanks. The third one is the aged or damaged condition of the spillway and sluices and other structural element of the tank. These are another issue in the tank. Mostly one or more than one issues are found in the tank. Better we can go for the rehabilitation or upgrading. I think in this manner we will think about our Kalmadu tank. I think you can see these photos. There are huge quantum of water is stagnated in the downstream area. I think this water is seeping through the body of the embankment and stagnated in the downstream area. This severe seepage one day will create a lot of disaster. That's why we are highly worried about the seepage condition. This is the erosion of the upstream and downstream of the embankment. I think this was happened due to the not proper cover in the embankment area. In the upstream area also, there is no any rubble packing or any protective arrangements were not there. In the downstream also, there is no any turf cover or anything in that tank. And if you see these photos, I think you can see this is the sluice tower, very aged condition. I think definitely need to do some repairs to serve to the people or tank. I think all three issues are found in the Kalmadu tank. Thereafter, our irrigation department, we recommend to do some rehabilitation, including augmentation. I think in that scenario, we are requesting our design branch of irrigation department to do some designs to improve this tank without changing the HFL level. I think based on the design, this is the proposed hydrodate of Kalmadu tank. It was prepared based on the design output. I think present capacity of the proposed capacity of the tank is around 14,840 acre feet. Additionally, we can able to store more water. I think around 2,500 acre feet of water we can able to increase additionally. I think through this additional storage, we can able to cultivate more than 500 acres. I think before starting the construction program, we did some borehole testing at 12 locations in order to see the inside condition of the embankment. In the meantime, to determine the SCB wall depth we are proposing, for that purpose, we did the borehole investigation at site. Actually, during the design stage, we are thinking about the seepage control methods because this is the very poor seepage condition, very seepage condition in the embankment. Then we think about the seepage control methods. There are various methods are available, but here 5 methods I have mentioned here. I think if I consider the first one, concrete barrier wall, normally it is called as a secant pile. It is not practicable to our country because of the high cost. The soil wall also, I think clay puddle core wall, actually it is possible because for the new construction. In the case of the improvement work, it is very difficult to do that work. I think upstream blanketing also very high cost. Then we think about the third and fourth methods. I think fourth also not suitable. Already we did in the Peraro project in Vaunia, but there are some issues in the SB wall also. By comparing with the SB wall, SCB is the most preferable one. We did in the early Iranamadu. This is the first time SCB was implemented in Iranamadu. The second work implemented in Kalmadu. This is most appropriate one to prevent the body seepage of the embankment. Apart from that, some other features are available to this SCB wall. Possible to cut off the pre-existing seepage or piping pathways of the embankment. The another one is the anticipated permeability value is very, very less, 10 to the power minus 10 meter per second. This is the another benefit of the SCB wall. I think normally for the clay wall, the seepage value is around 10 to the power minus 6 meter per second. By comparing with the clay core, it is more realistic one and more effective one. The effective, comparably, the cost is also very, very less. I think the present cost of the SCB material, including excavation and filling everything, 15,000 rupees per meter cube. But in our Iranamadu case, the contractor bidding stage, they quoted the rate is around 7,500 rupees per meter cube. Comparably, very low cost method. And another benefit is less harm to the surrounding environment. That is the another positive point of this SCB wall. The last one is the advanced skills and technologies are not required. By comparing these all benefits, we selected the SCB wall for this embankment improvement work for the Kalmadu rehabilitation. Then in the meantime, we are receiving money from the Integrated Watershed Water Resource Management Project funded by the World Bank. These are the contract detail mentioned here, the name and contract amount. Altogether, without that, the total contract amount is around 484 million, but the price of present escalation and all, the present cost is around 800 million. Altogether, contract period 2 years. Other details are given here. These are the construction sequence. Normally, we are following these construction sequence in every way of the improvement works, except construction of SCB wall. We will think about the construction of SCB wall later. Based on the design calculation, the proposed embankment plan and cross-section were developed by the design branch. Here, upstream part and SCB wall part and downstream part mentioned here. We will see one by one clearly. This is the SCB wall locations. In this section, SCB wall top level, almost we plan to maintain around 0.6 meter below the proposed BTL. At the same time, the width of the SCB wall is around 0.6 meter. And based on our geotextile or borehole investigation, we decided, or we decided, because of the fund limitation and machinery availability and all, 10 meter. Actually, this the SCB wall depth, it is below the downstream level of the downstream level. These are the main features, and we plan to implement the SCB wall 200 meter chainage to 1240 meter chainage. I think within that area only we plan to construct the SCB wall. Beyond that area, we don't need to maintain the SCB wall because that area is high elevated one. Then no need to put the SCB wall. This is the SCB wall section. The other one is the upstream bund section, and the upstream bund section normally we are placing the rubble packing over the gravel laying. But this time we are additionally laying the geotextile material below the gravel layer. By providing the geotextile material, we can able to protect the sediment movement of the particle movement from the embankment. This is the additional benefit we are introducing this time here. This is the downstream section. In the downstream section, the slope is 1 and 2.5. All the components are mentioned here. The sand chimney, vertical sand drain and finger drains and toe drain, toe road, everything we have mentioned here. All are designed by our design unit of irrigation department. Based on that, this section was developed. This is the SCB wall construction sequence. Normally, this matter will discuss my friend in later. I think anyhow, I have touched some part here. The SCB wall construction, we are dividing 2 or 3 components. The first one is I think this is the common part. I think we will think about one by one here. This is the first one. The first one is the excavation part. Excavation for the SCB wall filling. In the excavation part, the initial setting out is the first thing. The second one is the platform preparation. Normally, we are doing the platform preparation to move the vehicles, excavators and some dump trucks and all the vehicles to move here and there. We have to do some platform preparation is needed. The other one is the setting out, and the fourth one is the trench excavation. This is the chainage we have planned to do the SCB wall work. Normally, in the deep excavation, we need without Bentonite slurry, we can simply excavate. For that purpose, we are pumping the trench slurry, Bentonite slurry inside the trench. After material, we have transported and dumped to the proper locations. I think after filling the SCB material, we are sending the in-trench slurry to the desander. I think desander is removing the unwanted particles, and we are getting the Bentonite slurry. Then we reuse the Bentonite slurry for excavation purpose. This is the second stage. The third one is the important one. We are mixing the cement slurry, bentonite, and soil. These are the 3 components we are using for the SCB wall preparation. Normally, there is no any standard. Only based on our past guidelines and past experience, we are mixing the SCB material. We are preparing the trial mix, and we are making the trial mix and send the trial mix to the university to check the permeability coefficient. I think based on the permeability test results, we are selecting or we are approving the SCB mix design. Based on the mix design only, we are implementing the work at site. In that manner, we are preparing cement slurry, unhydrated bentonite and soil in the approved percentage. Then we are mixed with the excavator, and sometimes we are using some bucket and some tractor also. Then mix the mixer thoroughly. Thereafter, we are transporting the SCB material and to the required location, then placing into the ground. This is the normal process we are following. I think this subject we will our friends will explain very clearly. Normally, this is the we are preparing two slurries. First one is the initial slurry or French slurry. That detail is given here. The another one is the backfilling material slurry. I think that the detail also he will give. I think this matter also discussed in later in detailed manner. This is the 3D view of the 3D, not 3D view, some photograph. It is explained about the SCB wall activities, excavation and backfilling. All the matters are discussed here. I think you can imagine the SCB wall work through this picture. These are the real photos from getting from our site. I think the first one, second one, third one, those are put in here. I think after filling with the SCB material, you are seeing the photos here. I think after filling the SCB material, we are putting the end cap to minimize the damage to the top surface of the SCB material. The next one is the geotextile laying. This time we are introducing new thing. I already mentioned that this one also. Below the gravel layer, we are putting the geotextiles to protect the slope particles without affecting any wave action or anything. Yeah, this is the vertical drain. Normally we are cutting and putting the sands in the vertical drain of the downstream structure. This is the normal process we are doing here. This is a finger drain work. I think in this normal finger drain works, normally we are cutting the finger drains and we are filling the coarse aggregate. Over the coarse aggregate, we are placing the fine aggregate. Above that, we are putting the earth. That's the normal process. But normally, the finger drains are mostly affected by the particle movement inside, and all the voids are blocked with the particles. And after a few years or few years, the function of the finger drains are fully blocked. Due to the blockage of the finger drains, there are a lot of issues are created. But this time we are using some geotextiles to cover the coarse aggregate fully. Then there is no any chance to enter the adjacent particle into the coarse aggregate. Then we can ensure that the finger drain functions almost all the life period. Function is at the perfect condition. That is the expectation. This time we are introducing here. This is the sand simony work. We are putting the sand simony in the downstream slope of the embankment. These are some photographs showing that activities. This is the site visit of the World Bank people. I think this is the starting time. Some Japan expert and Indian expert also came with the World Bank team, and they are explaining the real nature, and they are expecting some, especially they are expected how we are implementing the SCB wall activities and all. I think next month they are coming to the site to assess our work progress and all. This is our local level officers. They visited the site, including DCC chairman and GA and some other local parliamentarian. They came to the site and see the situation. These are the some site photos. This photo is showing the site progress and site meeting. Everything every week we are conducting the site meetings with the contractor. That is the plus point to accelerate this work program. Okay, thank you, madam.
Thank you very much, Engineer Karunanidhi. It's a very elaborative presentation and very informative presentation on the approach, how you selected this technology out of many options. And I'm sure the audience would have got a very clear idea on your approach. So you explained very clearly from the basics why and how you selected the method and how it proceeds. So I hope there are a lot of questions coming in here. I can see in the chat box. I hope your members will note of all these things. So the next presenter is engineer. I'm sorry.
Vaiharan.
Okay, thank you. Yeah, the next panel member is Engineer Vaiharan. He graduated in 2020 with the BSc Honours degree in Civil Engineering from University of Mortua. He commenced his career in 2021 as an irrigation engineer at the Department of Irrigation in Northeast Provincial Council. He involves in designs of irrigation schemes and contract management of augmentation of Kalmadu irrigation scheme. So over to you, Engineer Vaiharan.
Thank you, madam, for your introduction. So with those previous presentations, we are now moving on to fundamentals of SCV wall construction. So here we are going to discuss about SCV wall construction. So now with the two previous presentations, you may know what the term SCV means. So it is an abbreviated form of soil, cement, and bentonite. But we have to deal with some other material also, that is water. So SCV is a mixture of these four materials. But now we are discussing about not the term SCV, it is about SCV wall, soil, cement, bentonite, slurry wall. So that barrier wall, that is the vertical barrier wall, is used to prevent seepage. So we have something to deal with seepage in Kalmadu project. That's why we are planned or proposed to build a vertical barrier wall. So to build a vertical barrier wall, we have several methods. Here in our site, we choose slurry trench method. So if we have a look about slurry trench method, so slurry trench is a narrow vertical excavation done using slurry trench method. So that slurry trench method is done using the support of bentonite slurry. That is exactly what we are using in pile foundations. So slurry trench will be excavated using the support of bentonite slurry. So that slurry wall, if we have discuss about slurry wall, the slurry wall is a deep barrier wall. It will be used whenever conventional open cut methods are not possible. So in Kalmadu Dam, we have an already existing embankment. So it is not possible to remove the entire embankment and do a new conventional open cut method, clay wall or some other walls. So that's why we were in a situation to go for a slurry wall. So slurry wall, we can construct slurry wall for various purposes. I have listed out 4 here, but here in our application, we will be only dealing with seepage control. So this is a typical slurry wall. That slurry wall do have various other types. So I have listed 3 types. There are many types as well, but I have listed 3 types based on the materials used for the backfilling purposes. So soil bentonite, we use soil and bentonite. Cement bentonite, we use cement and bentonite. Soil, cement, bentonite, that is what our case is. We use soil, cement, and bentonite for the as backfilling materials. So if we have some comparisons with within these 3 materials, soil bentonite will give very low permeability than cement and soil cement bentonite. Cement bentonite will give higher strength but low permeability when compared to soil bentonite and soil cement bentonite. But CB wall, that means cement bentonite wall's permeability can be improved with time. Soil cement bentonite will be will give relatively higher permeability than soil bentonite, but it can give more strength than both SB, that is soil bentonite, and cement bentonite walls. So with these types of slurry wall, we have selected SCB wall as our for our application in Kalmadu tank. So why we have selected soil cement bentonite wall is most of the advantages of SP slurry walls, that is the conventional method of slurry walls. So most of the advantages will apply to SCB walls as well, but it has an additional advantage that it can give higher strength than both SP and CB walls, and also it will give greater trench stability, which will help us in implementation than using other two materials. So now we have to deal with the material preparation, because these materials we are talking about, soil cement bentonite, OSP, or CB, in our case soil cement bentonite, it's not readily made available for us. So we have to prepare those materials for our needs. So here in this SCB wall construction, we have to prepare different types of materials. One is obviously we have to prepare the backfill material, that is SCB backfill material in our case, and also we have to prepare bentonite slurry that will be used to excavate using slurry trench method. For slurry trench method, we need slurry to support the excavation. So we have to prepare that slurry as well. This is the slurry we are using in pile foundations as well. So these SCB material preparations will be done by mixing bentonite slurry and cement slurry with soil. So bentonite and cement slurries will be mixed with soil rather than adding bentonite and cement dry powder, because we need to prepare a homogeneous mix of SCB material. So it's always recommended to mix bentonite and cement in the form of slurry than going for a dry powders. This is the flow chart for SCB backfill material preparation. So basically we will prepare bentonite slurry, cement slurry, and we will mix those two slurries with soil, and we can get the end product, that is soil cement bentonite material, that is SCB backfill material. So we will see about all these materials one by one. First one, if we see about bentonite. Bentonite is basically a clay material that has a high percentage of this compound, that is montmorillonite. It is a mine product. So generally bentonite is formed due to volcanic eruptions. So the countries have volcanoes may reach in bentonite. So bentonite has a special property that is called cation exchange capacity, which makes them useful as adsorbents and binding agents. This is the properties why we use bentonite as a drilling mud in pile foundations or slurry trench as a slurry trench supporter. So bentonite itself has many types: sodium-based bentonites, calcium-based bentonites, magnesium, potassium. There are many types, but usually we use sodium-based bentonite. Sodium-based bentonite is generally called as bentonite. Other bentonites are very less in our applications. So we will see about sodium bentonite. Basically, sodium bentonite is a swelling clay which has sodium plus as the exchangeable ion. That is what the name came from, sodium. If it has calcium 2 plus as exchangeable ion, then it will be a calcium bentonite. So here it is the swelling clay will have sodium plus as the exchangeable ion. Also, it absorbs large quantities of water and can swell to many times the original volume and can form a gel-like masses. Exactly for what we can use bentonite as dam sealant or waterproofing material, or in our case as drilling muds. So these bentonites have some other special properties. I have listed out 6 which we need in our applications. So we will quickly go through those properties. So bentonite has strong colloidal properties. That means bentonite is stable as a colloid, which will help bentonite to migrate through a geological media without any retardation. That means bentonite will not form a sediment like this. Unlike other materials, it can stable as a colloid. And bentonite will swell when it comes to contact with water. So this montmorillonite compound will swell up to 5 to 15 times of its original volume when it comes to contact with water. Water absorption, just as we discussed, bentonite can absorb water up to 4 to 5 times, and at the same time it can swell up to 5 to 15 times, which makes it useful as a drilling mud. So high viscosity, bentonite has a high viscosity. That means it has resistance to flow. From this picture, you can see if a fluid can possess high viscosity, that means it has some resistance to flow, which we need in our applications. So high plasticity, that means we can work with bentonite without changing its other properties. So thixotrophy is an interesting property to look out. Thixotrophy is basically a decrease in viscosity when we apply a force or stress, and it will go to its original viscosity if we remove that stress. So this is what we experience normally in pizza huts while we used to get out sauce from sauce bottles. So if we can apply a force on sauce bottles, it will flow. Otherwise, it will stay as a high viscous fluid. That is exactly what we do in painting. If we can apply brush, it can flow. Otherwise, it will stay as a high viscous fluid. So bentonite has a high viscosity. That means that is positive for us. And at the same time, at few instances, we need bentonite to flow freely. For that, we can make that high viscous bentonite fluid to flow as per our requirements. So this is what all about bentonite, and we will see about water. So water, just we can use fresh water with free of some deleterious substances. I have given some properties and some requirements, that is the common requirements of fresh water. So if we can use fresh water within these limits, we can get a desired mix for our SCB backfill material. So the next one, cement. We can use both type 1 and type 2 Portland cements. Basically, type 1 is general purpose cement and type 2 is used in water-related projects. Even though type 2 cement is recommended, there are proofs that we can also use type 1 cement and can get our desired results for our SCB slurry wall applications. So as we discussed earlier, cement will be mixed as a cement slurry to form a homogeneous mix. So with that, we can prepare bentonite slurry and cement slurry, and these slurries will be mixed with soil. So soil can be just as how we using clay soil for embankment. We can use that soil. So if we have to be specific, that 20% material passing through number 200 feet, that is 75 micrometer C, it is enough for us. So depending on the soil, the bentonite content and cement content will vary. So if we choose a quality soil, then we can reduce the bentonite content and cement content. If we have a comparatively poor soil, we need to add more cement or bentonite contents to get desired SCB backfill material fill. So from this, we can move on to SCB material. So in mixing SCB material, we have bentonite, cement, and soil. With these three materials, we have to mix in different proportions, and we can do trial mixes, and we can get which proportion will gives us the desired results. So these are the desired results. The main deciding factor is permeability. We need to get permeability lower than 10 to the power minus meter per second. And also we have to monitor these three properties as well while we are doing trial mixes. So in this case, we did 3 trial mixes. These proportions are based on the past experience, what we get in Kalmadu. So we did for these 3 samples, we did trial mixes for these 3 samples, and we have selected sample C, I think, yes. We selected sample C as it gave us the lower permeability among these 3 values. All these 3 samples were within our permeability limit, but sample C is the lowest among it, and also it satisfied our other parameters as well. So this is the proportion now we are using in Kalmadu tank. So this is all about the preparing about SCB material, that is SCB backfill material. We have one other material also to prepare, that is bentonite slurry for trench excavation. So same as SCB backfill material, bentonite and water will be mixed in different proportions, and we can watch out these properties to get our desired mixed proportion. So in our case, we got 6% as our bentonite proportion. That means 6% bentonite and 94% water will satisfy our needs. So this is what the material preparation is. So from this, we can prepare SCB backfill material and also supporting materials for a construction of SCB wall. So these are the specifications that I have discussed this time. This is bentonite powder, specifications for bentonite powder. We have now discussed about the properties. So according to those properties, we have these values. These are some kind of empirical values used in various other applications. Various other applications is similar to our applications. So water we have discussed, and here initial bentonite slurry we have discussed, and SCB backfill material we have discussed. But here I have added one other material, that is in-trench bentonite slurry. So for the SCB backfill material, the trench will be filled with initial bentonite slurry first. That means the trench slurry to support the trench excavation. But within the trench excavation, the bentonite slurry can be mixed with soils. That means that the properties will may can change. So we have to monitor those properties as well. So for that, we will every time we backfill the trench with SCB material, we have to monitor density, that is unit weight, and viscosity as well. So these three materials will be within our monitoring every time we use SCB backfill material. So SCB backfill, the construction process and the tests we are doing in site during the SCB backfill material construction will be explained in the next presentation. Thank you.
Thank you, madam.
Okay, thank you very much, Engineer Vaharan. Thank you. It is a very well organized and simple presentation that even a layman can understand the theory behind the selection of material and also the mix design. You explained very clearly how the material characteristics will play in the mix later on. Thanks once again, and we hope we can have your intervention during the presentation as during the discussion to the questions asked by the audience. Then our last presenter will be Engineer Sanoj. He graduated in 2017 with BSc Honours degree in Civil Engineering from Southeastern University of Sri Lanka. He commenced his career in 2018 as an irrigation engineer at the Department of Irrigation, Northeast Provincial Council. He is directly involving in construction supervision and quality assurance of Kalmadu irrigation scheme augmentation project. So hopefully we can hear a lot of more things what the engineers experienced during the implementation of the project. Engineer Sanoj, it is your time.
Thank you, madam. Good evening to you all. I'm going to talk about the construction and quality assurance of SCE wall. Here, the SCE wall construction, we can divide it as a major three part. First one is the excavation. Second one, SCE backfilling material mixing. Third one, SCE material backfilling. So first excavation is we are going to excavate 10 meters. So we are using we are doing the excavation by using trench slurry. Earlier presenter is present as present. We are using 6% bentonite and balanced water. We are making one slurry. That one we are going to use for the excavation. Second one, we will do the backfilling mixing. When we are doing the backfilling, the slurry, trench slurry will be removed from the trench. Backfilling material will be placed. by this one we can make a SE wall. In the site, these are the tests we are doing. Mainly three items we need to check. First one, initial bentonite slurry. This one we are using for the excavation. Second one, in-trench bentonite slurry. That's one, before placing the SCB backfilling material, we have to take the sample from the trench and doing the test. Third one, SCB backfilling material. That's mean soil, cement, bentonite all together we mix. After do the proper mixing, before placing the trench, we are doing those tests. Slurry preparation. In this construction, two kind of slurry we are using. One is initial bentonite slurry. That's mean this is supporting for the excavation. Second one, bentonite slurry for the backfilling material. Actually, the bentonite slurry for the backfilling material, we are not doing any kind of test. Just we are doing the bentonite slurry to get the proper homogeneous mix with the soil and cement. So initial bentonite slurry, we are doing the mixing 6% bentonite and 94% water. For the backfilling material, we are using 9% bentonite and balanced water. This 9% we have fixed according to the site condition. Actually, this will be fixed with the available pump capacity and water requirement. If you increase the water, then the water cement ratio will be high. If we reduce the water, then pumping pump by the machineries will be difficult. So third one, those bentonite slurries need to be stored in the pond because of hydration. Actually, bentonite slurry will be get a hydration. With the hydration, it will come as it will doing the swelling and get as a hydrated material. So before we using the bentonite slurry, both slurry, the initial bentonite slurry and backfilling material slurry, we need to keep at least 24 hours in the exposure condition. So we keep the mixing slurry in the ponds. Third one, another one, cement slurry. Actually, cement slurry we cannot mix and keep it because it's will getting hardened. So during the backfilling material preparation, we do the cement slurry mixing and use it the same time. These are the ponds we are using for the bentonite slurry storage. Here we excavate 4 ponds. And mix the bentonite slurry as per the required percentage, then stored in the pond at least 24 hours. Here you can see the ponds how we are stored the bentonite slurry. Here you can see some gauges. Those gauges fit in the 2 ponds. Those slurry we are using for the SE backfilling. That means this we need the capacity for certain amount of soil. We need to pump certain amount of slurry. So we calculating the quantity of slurry and pump from this pond. For that purpose, we are using these gauges. Cement slurry preparation. The cement slurry preparation we will do in the same time of backfilling material preparation. We are using the bentonite mixer for the cement slurry preparation. We just mix it and mix with the soil and bentonite slurry. Okay. From first stage is the excavation. For the excavation, first we have to make the platform. In the platform, we first mark the location of SE wall locations. Then for do the excavation, we need proper equipment. Actually, here we are using long arm excavator. The excavation equipment need to able to cut 1 meter more than SCB depth. That means here we want to do the SCB wall 10 meter, then the excavated equipment able to cut 11 meter. Actually, our using excavator can excavate 11.5 meter depth. Second one, we are doing the excavation in the constructed bund. So very experienced operator needed to do the excavation, because the excavation should not be damage the constructed bund. First thing. Second thing, the excavation should be done within the slurry. When we start the excavation, we fill with the initial bentonite slurry. So at the time, without can't see, without visible area, we have to cut up to 10 meter. So the to get the good workmanship, the experienced operator need to be run the work. Third one, the platform level. We need to have a vertical SE wall. To do the vertical SE wall, the platform should be leveled properly. So if the platform in horizontal, then only we can get the vertical strength. So here we are using the tolerance to 3%. Same time, when we are doing the excavation, we will fill the slurry continuously, because to stabilize the side walls, we have to keep the slurry from the top of the excavation to at least we have to keep 500 millimeter height. So continuously, when we excavation, we are pouring the bentonite slurry. These are some photos of excavation. Here you can see in the first photo, we have marked the lines setting out. Then we check the verticality. Then we have start the excavation. The last photo shows that we are filling the initial bentonite slurry into the stage. This photo shows how we are checking the horizontal of the platform to keep the vertical SEO. This is how we are checking the depth after the excavation of trench. Okay, next thing is the backfill material mixing. Here we need to prepare one mixing jar. Then the soil should be deposited in the mixing jar. That soil should be 15% to 85% passing 75 micron seed, as earlier presented. That material we are using. Here we are using more than 40% passing 75 micron soil. Depending on the volume of soil, we are pumping the bentonite slurry. That means we already prepared the bentonite slurry for the backfilling material. That quantity we will calculate and pump into the soil and mix it. Then with the mix, for the mix, we will calculate the required quantity of cement and mix with the water and make it as slurry. Then we mix with the earlier mix. Actually, here we have to follow this procedure, because we cannot mix cement slurry and bentonite slurry in same time with the soil, because we already tried. If we mix like this, we can get some clogging. And first time we cannot mix the cement also, because cement will be hardened early. So first we have to mix the bentonite slurry and get proper mix. Then only we can mix the cement slurry. Then the mix should be mixed throughoutly. For the mixing, we are using excavator and tractor. Here we are using tractor with the rotavator to get proper mix. Finally, after mixing the SAV material, we check the slump and density. If within the limit, then we transport the material to the filling area. This is the SAV mixing jar what we are using here. These are the procedure. First, we are depositing the soil, then pumping the bentonite slurry. then mixing the bentonite slurry with the soil, then we are coming the cement, then cement, bentonite, mix, soil, all are mixing together. Finally, with the tractor and rotavator, we are mixing and get a good homogeneous backfilling material. These are the same photographs. Finally, we are going to place the SAB backfilling material into the trench. So first we are transport the backfilling material and dump it nearby the trench on the steel plate. Then we push with the bobcat to fill the trench. Before place the backfilling material, we are checking the in-trench slurry quality. That means when we for the initial bentonite slurry, during the excavation, that mud particle and another contamination due to another contamination, that density of the slurry will be high. So we have to check the density of in-trench slurry density and backfilling material density. That backfilling material density should be more than 15 PCF of in-trench slurry. Then only the backfilling material can be go inside and replace the in-trench slurry material. That means the density should be high, then only can go down and can be replaced the in-trench slurry. While pouring the SE material, that in-trench slurry may be overtopped. Due to the reason, we are taking out the in-trench slurry continuously. Another reason also there, if the in-trench slurry density is high, we have to dilute it. So we remove the in-trench slurry, then pour the initial bentonite slurry to do the dilution. The removed in-trench slurry will be pumped to the desander to remove the sand particle and unwatered material. Then the trench slurry which is come from the desander, we check the quality. If the quality is adequate to reuse, we will reuse. Otherwise, we will dispose this in-trench slurry. This process will be continue to construct the SE wall. Strength backfilling. Here you can see the first photo how we are deposit the backfilling material. Second one shows the bobcat. Then finally, final photos you can see after the construction of SE wall top. These are the testing we are doing in the site. First is moisture content. Moisture content we are checking for the soil because of the our mixing ratio is the dry weight. So first we check the moisture content of the soil, then calculate the dry weight of soil. According to that, we are calculating the bentonite and cement. Second one, viscosity test. Viscosity test we will do for the initial bentonite slurry and in-trench bentonite slurry. Density test. Density says we will do for all three: initial trench slurry and in-trench slurry and backfilling material also. And filtrate loss test. Filtrate loss test we will do only for the initial trench slurry to check that quality. And slump count test. Slump count test we are checking for the CV backfilling material. It should be 120 to 200 millimeter slump to get good workability. Finally, this is the permeability test. This one we cannot use do it in the site. In Sri Lanka, I think it can be do only in the Moratuwa University. These are the photographs got from University of Moratuwa. Okay. Here we have prepared one video to get good understanding of the SE wall construction. We will go to the video. Thank you, madam.
Thank you.
Thank you, madam.
Okay, thank you very much, Engineer Shanoj, for your very informative presentation. Most of the problems actually I had at the beginning of the panel discussion were addressed by your presentation on the methodology of you adapted. I'm very happy to see Engineer Sudhakaran that the scientific approach you all have taken to identify the problem and also to prepare the remedial measures, remedial plans in par with the international standards. So congratulations to the Northern Provincial Council team led by Engineer Sudhakaran for your excellent presentation summarizing all what you have done so far. I think this is the time for the discussion. We might spend about 15 to 20 minutes maximum of I mean, after the discussion, so we will take up first the questions posed in the chat box, and others who are having the questions still in their mind can raise your hand, please, and then we can unmute you and get the questions. I am not going to repeat the questions, Engineer Sudhakaran. You all can read and answer one by one. Is that all right?
Yeah, yes, madam. We have seen
Okay.
all the 13 question raised. So one by
Okay.
one, we can answer for that. We are ready on that, madam.
Thank you.
Okay to do that.
Yeah,
Madam.
that will be fine. Yes.
First one is can you show the SCB? Can you explain about the bedrock condition, permeability of the dam section? That was the first question raised by someone. So why don't you, Kalmadu?
Yes. I think we did the borehole test up to 16 meter from the existing BTL, but we didn't receive any bedrock condition. I think all below the existing bed level, we can go up to 6 meter. Within the embankment vicinity, there is no any bedrock.
So beyond that, madam, during the restoration time, so we have gone 10 meter below the ground level. So during that time also, not any bedrock issue here. As per the bed formation in that area is too deep. Even during the Kalmadu time, we did some SPD test as well. So that gone beyond 80 meter like that. So we don't much worry about that. Yeah. Second question is, are there any treatment works done for the bedrock to control the seepage through the bedrock? No.
Yeah, that is possible, but without SCB. By using SCB, we can control the bedrock crack control or seepage control. If there are any crack or any seepage in the bedrock, definitely we have to do the high pressure cement grouting is the possible way. By using the SCB, we can do it.
The third one, how do you ensure the durability of your textile? I mean, what is the time duration that it will be working without blocking? Yes.
Based on the manufacturer specification, the life period of the geotextile is around 50 years. I think in that manner, we are working at the site.
Other one, usually 7 days SCB strength should be 100 to 200 kPa kilopascal. But in this project 0.2 to 1 MBA. Is this correct?
So generally, this 0.2 to 1 MPa value is a common value that we can expect for a SCB backfill material. So basically, the concept is it will give higher strength than SB and CV. So SB for that value is somewhat about 100 kilopascal. For cement bentonite, we can go up to 0.5 MPa. That means 500 kilopascal. For SCB, we can get in the range of 0.2 to 1 megapascal. So anyhow, these values are not the deciding factors for us to decide we have to use SCB. So this is general values from some literature, previous experiences.
So, thank you, Vagaran. Other one, what about durability of this sub method with the compare other conventional method, SCB method, with the compare with other conventional construction method in economically?
Durability of the SCB similar to the conventional method, not more or less, but in the comparably the SCB work is a high cost method compared with the conventional method. Conventional method normally we are using the clay and other local material. That's why we don't need much amount.
So yeah. Rather than cutting entire bunch, only trench only we are cutting. So the quantum of material also less. That part also there. So other one is the question. Thank you, Karnanidhi. Did you any admixtures to increase the setting time of cement?
Yeah, during the SCB wall work, we are not using any admixtures to extend the setting time. But normally we are unloading or we are placing the SCB material within 45 minutes to 1 hour in the required location. That is possible.
Thank you. Other one, can you show the SCB trial mix results, UCS and slump? Yeah.
Yeah, this is the test report received from the university. The average coefficient of permeability value is given here. That is around 10 to the power minus 10 value. That's the first one. The second one is what's the second one?
Slum, no? Slum.
Yeah, slum always we are testing at our site. I think if you come to the site, then you can see the reality and everything.
Thank you. Other one, thank you for the presentation. This technology was applied in preventing seepage of leachate from Sundarapala carbate dam in Kurnagala and was found successful. That's the positive comment on that. The other one, for this project, have you accommodated any instrumentation for the long-term monitoring purposes?
Yeah, this time we are trying to install the piezometer to monitor the seepage and other observation. At the same time, easily we can observe in the downstream area. Now the downstream area, very huge quantum of water is stagnated due to the body seepage.
This is we practicing in Irrigation, madam. Yes, we continuously monitoring piezometer head and down. Yes. So in addition to that, the seepage control also we are going to provide V0 for the measuring. The similarly we do in Irrigation as well for the seepage monitoring measuring. So other one, thank you. Did you check the institute permeability of SCB after construction?
Yeah, it is impossible, but in the same time, we are sending the site mix to the university. Now under testing, I think we are testing and check that values. After getting the results, we can have some idea about that one.
So thank you. Other one, what was the used disposal methods for Bentonite to mitigate environmental impacts?
Yeah.
Those material we are using for the backfilling of the downstream pond area. That means excavated pond are in the downstream. So this bentonite clay mix give a good additional barrier to the seepage.
Yeah, thank you, Sunoj. Other question, any compaction method required adapted after placing SCB into the trench? That's a good question. Yeah.
No need to apply any
Yeah.
compaction method. This is a self-compacting
Yeah.
property material. Definitely, if we place the material inside the trench, automatically it will compact and compact to the required standard.
That may be the reason, one of the reason for choosing SCB material, because of the self-compaction, because the trench, we cannot do the proper compaction like other embankment sections.
Yeah, mainly we have to maintain the slump. That is very important to ensure this compaction, self-compaction. Yes.
Right, and thank you. Other one, you directly dump the SCB into the trench. Then how about segregation of SCB?
Yeah. I think due to the self-compaction, there is no any segregation occurred in that site.
Thank you. Other one, suppose mixing in put mill, simply in concrete truck mixer with a pump car would enhance the quality and reduce the risk in collapse ranges than mix all in bare ground, isn't it?
Yeah, actually, this method we already try in the site with a concrete car, that's a transportation car. We cannot mix the SCB. We try, but the result is fail. But the concrete mixer we can use for the mixing, but the quantity of mixing is very less. Actually, one batching we are mixing three tippers. That means 9 cube soil. That much of quantity we cannot mix with that one. And per day we are doing 3 or 4 batches. So time will be taken to do that work with the concrete mixer.
Thank you, Sunoj. The other question is, what is the sand percentage of soil? I'm asking this question as greater sand percentage can form a permeable layer at the bottom of the trench.
Yes, we have to use high clay content soil for the mix. So obviously, as stated in this sentence, high sand percent can make permeable layers. But anyhow, we are going to mix this soil with bentonite and cement, and eventually we will check the permeability. So we will allow only the material which have low permeability values, that is within our limits. So if we use high quality soil, that means high clay content, we can reduce the percentage of bentonite and cement. If we are going for a low quality soil, that means with high sand percentage, then we have to match up with bentonite content and cement content. Usually that is not recommended. We have to go for high clay content soil.
Thank you, Vaigaran. The next question was, what are testing you did to verify performance on indebted quality after construction?
I think after construction, immediately we can do any verification, but now we are installing the piezometer and V notches and everything at the site. I think during the rainy season, we can ensure the performance of the SEV wall.
So thank you, Karna. The next one is what are the main properties of soil that will suitable for SEV?
Actually, for the SEV wall, we can use any kind of soil, but if we use the sandy clay or the soil which is have more clay content, that will be good for the SEV. That means we can reduce the cement content and bentonite content. And if we can add more, we can use any kind of soil.
Thank you, Sunoj. So the next one is what are the main properties of soil? Any rectification methods practiced to maintain desired verticality of the range, which went wrong at the excavation stage?
Yeah, normally the trench tolerance is around 33%. That is the required vertical. Definitely, we have to ensure the trench in the vertical locations. The tolerance is maximum 3%. But if sometimes there may be some problem, but in that case only we are losing some SEB filling material. That is the only problem. But the contractor bear that cost. But we are not giving any money, any additional money for that work.
All right, thank you, Karnalji. The other one is what are the main factors of deciding the range depth? Is it the main availability of the
The main is the carefully evaluate the site condition and project requirements is the main reasons to determine the appropriate depth of the SEB wall. Some factors are there. I think actually the seepage analysis is very important one. Another one is the permeability of the soil, and geological condition also another factor influencing the SEB wall depth, and design requirements also another factor. The construction consideration, I think in our side we are having only the 10-meter long arm excavator. That is another factor. The safety and stability, the environmental impact and others. There are so many factors, and based on the key factors and with our site requirements, we will decide the maximum depth. Actually, if we bring the SEB wall up to the bedrock, it is more ideal. But depending on the site requirement, we will decide the depth. That is the final decision.
Ultimately, the depth of the SEB wall should be determined through the comprehensive geotechnical investigation and analysis involving site-specific data collection, laboratory test, and all. So, unfortunately, for this is based on our basic data only, we could be able to locate from the site specific site condition. Yes. The last one. What were the potential challenges and risks associated with the using soil cement bentonite in barrier wall constructing in this project, and how they were mitigated? I will repeat. What were the potential challenges and risks associated with the using soil cement bentonite in barrier wall constructed in this project, and how they were mitigated?
Yeah, I think normally up to now we are not facing any challenges, but anyway, for the guidance and all, we are having one experienced person at site. With the help of him, we are executing the work. But the early stage, we are thinking about that some difficulties, but during the execution, everything is very simple. I think in my slide, I have mentioned that there is no much skill and much technologies are not required to do the work. I think in our past experience, there is no any difficulties faced during our construction period.
So as I explained, Karnalji, so really during the design, so we could not consider the much of due to the limitation for the SCB depth and all. But as I explained, so the site specific condition, we could able to achieve remove that barrier. That is the main challenge. But fortunately, so we have got a good contractor with a very experienced SCB wall experienced guy. So with that, by referring the literature, we could able to achieve. That is our challenge we removed from that. Yes. The other one, how you maintain construction joint during the lengthy construction of SCB wall, right?
Yeah. Here, no need to put any construction joint or anything because we are maintaining the SCB wall below the ground level. Otherwise, definitely it will get some damage because the SCB is the brittle material. Always we are maintaining the end cap over there. Normally we are maintaining around 0.6 meter above the SCB top to the open environment. I think no need to put any joint, any construction joint or anything at the location, but it is automatically bond with the new layer. That is the thing at site.
Thank you, Karnadi. Can you add something from the site itself, Engineer Sunoj? How do you it's without this construction, how it's bonding? Yeah.
Actually, this SCB backfilling material will not get hardened inside the Bentonite slurry. The top portion only get hardened. So before placing next day, we just remove the top part of the SCB material. That means the exposure condition. Then we can backfill the backfill material. So inside there is no any harden. That's all in the wet condition. So same time it can be bond together. No need any bonding things. Construction.
Thank you for the detailed explanation. All right. The next question. Keep on questions coming, madam. Is it okay to answer for all of the question, madam? We are ready to do.
Yeah, sure. Yeah, sure.
Really appreciated your team effort at site and the session. Thank you for that. This is especially answering for question. Are you all happy about answering, madam? Thank you. All the best team for the many application of SCB in Sri Lanka as such innovation. Thanks, Water Forum, for this sharing wonderful knowledge. Thank you. Sorry about this, not a question. It's a feedback from you guys. Madam.
Yeah.
One more, madam. Can you describe?
Yes, one more question. Yes.
End cap. Can you please describe about the end cap?
Actually, the end cap meaning after construction of SCB, we transport in a vehicle or if load, the top part of SCB wall maybe get damaged. So in the specification it says at least 2 feet high we have to fill with the loose soil. That soil we will not come back. Actually, with a flat form, we cut the strength 2 feet height of top of the SCB wall. So the balance 2 feet we will fill with the loose soil. Then we construct the bund with the compaction. So we call that 2 feet loose soil as a cap, end cap of SCB wall.
Yeah, there is another question. Is there any seepage and stability analysis done?
Yeah. Yes, madam.
Yeah. One more question is there. Is there any seepage and stability analysis done? Have you got that?
No, madam.
No. Right. So
Thanks for session and keep the good work for the betterment of the society. Thank you. Thank you so much.
Yeah. So I think you have covered most of the questions came up to most of us, I must say. I also had few questions, and all these were covered in the questions raised by the audience. Maybe conclude, Engineer Sudhakaran, with this.
Yeah. Of course, the time is okay, madam. So
Yeah.
whatever this presentation and video, everything can be shared. Our intention is to share the knowledge to everyone, engineers, because so honestly, we started in Kalmadu here, so we are almost nothing. But now we little learn. Still, we need to do. So there are some absence. Even for the SCB wall, so we have list out the how we depth can be determined. That for which we need to do some analysis, the hydrological analysis that need to be done. Definitely, we should have that design report for that also. Similarly, for exercise purpose, I am going to assign 1 or 2 engineers for the stability analysis and all the seepage analysis. What we did for the Kalmadu through the consultant, definitely we will do so for their PR and all. That's what we are planning, madam.
Thank you very much, Engineer Sudhakaran. Actually, that is what IESL expects from its members: progressive development in the technology and sharing the knowledge and experience with others for the betterment of the country as a whole. So, yeah.
No point of keeping everything with us. Even halfway, still not completed, but we want to share it because others can experience. Even there are a lot of people are coming and seeing. Even North Central, North Eastern provincial people are coming. They are going to do the same concept. They are the YMP people also willing to come. Like that, there are people are more coming. We are ready to with this presentation and everything because of really you only persuade us to do so. Thank you, madam.
Thank you. Then, Engineer Sudhakaran, congratulations to your team. Actually, you all showed your confidence on what you have done and what you are doing at the moment. So I must congratulate once again. To wind up the session, may I invite Engineer Yogaraja, our committee member, to deliver the vote of thanks.
It's my bad.
Good evening, madam. And actually, it is my pleasure to deliver the vote of thanks regarding this presentation, wonderful presentation. I think you can hear me, no?
Yes, my dear.
Yes, I can start with the panel members. Actually, my first sincere thanks goes to Engineer Sudhakaran. He did actually the marvelous job. It is a very, very difficult and very difficult to construct at the site, very difficult situation. But as a Northern Provincial Irrigation Director, he did initiative and carry out the very good job. And he clearly explained the Northern Irrigation Department function and other scheme also. Thank you, Sudhakaran, for your valuable contribution to this panel discussion. And further, second, my sincere thanks goes to Karunanidhi. He actually, at the site, he is a deputy director of Kilinochi Reach, and he is directly involving in the construction. He is the main person supervising that construction now at Kalmadu, and he clearly explained the Kalmadu and what is the problem there and everything. Thank you, Karunanidhi, for your wonderful presentation and your site experience shared with us. Thank you. And my special thank goes to Wire, and he is actually as a young member, he learned a lot and he delivered a good presentation to all the participants. And thank you, Wire, and you have taken up all the new SC wall fundamentation and all the theoretical part. Actually, it is a very, very difficult, but you explain very clearly to understand everybody very simply. And your effort is, we can't forget about that one. And thank you very much for that one. Similarly, that Sunoch is also the young member and he is in charge for the, I think, quality control on the site. He explained clearly and testing everything. He explained clearly to all the members of here in the IESL. And I think from him we can get more, but the time limit is a factor for that one. And Thank you so much for explaining everything. Also, I can't forget Water Forum Chairman also, Batra Kamalasa Madam. Actually, as a chairperson and a host, she coordinated very nicely this wonderful presentation. Actually, she spent the whole presentation all time and guide all the participants and all the panel members to do the presentation and tightly maintain the flow of the presentation. And thank you, Madam, for your wonderful effort and leadership for the Water Forum. And I can't forget that all the committee members of the Water Forum also to nicely arrange this presentation. Also, IESL president as well as committee members to allow this Water Forum to conduct this type of seminars to enhance the knowledge of the engineers in this country. And thank you, President, for IESL President, for this arrangement. And also the Provincial Council, Northern Provincial Council Irrigation Department, all the staff, because without all the teamwork, it cannot be successful. I think under the leadership of Sudhakaran, they have done a good job on that. Not only this time, that in Kalmadu also they have done. And thank you, Sudhakaran, and the team members of the Northern Provincial Irrigation Department. And also, I can't forget that all the participants, actually, they're very good enthusiastic participants. I think more than 110 through the Zoom, and maybe some more is participated at the Sudhakaran's office also, maybe physically also. And thank you for all the participants. Actually, it's a very good group. They have participated, and there are several, more than 25 questions in the chat box, and as well as there are 1 or 2 questions from the participant also. Then, but all the participants actively participated, and thank you for the participation and physically at their site, and as well as Zoom participant also. Thank you for your valuable effort and time spent with us in this panel discussion. Finally, I maybe forgot someone, and thank for everybody and every participation of this one. And whoever I forgot to thank you for all. And again, special thank goes to Batra Kamalasa Madam for this leadership, as well as Sudhakaran for his nice team effort for this one. Thank you.
Thank you, Joha, for your wonderful, from the heart you have you expressed. Thank you, my dear. So meantime, so I appeal everyone, we can give the email address. You can raise any question. In the meantime, we will share the Water Forum, whatever our document we have. So mainly presentation and the video to you all. So with that, I can conclude. Thank you, everyone. Keep this momentum always.
Thank you.
Sorry, yeah, sure. We will wind up with the thanks going to Chamara and the team who are there in IESL making us this all the logistics. Thank you very much, everyone. We'll wind up the session here.
Thank you.
Have a nice evening and good night.
Thank you, Madam. Thank you. Chamara can wind up.